Last time we were doing ideal gas law and we did some questions based on Boyle's law also. So what is the ideal gas law? PV equals to nRT. Now what was the Boyle's law? When all these are kept constant, constant. And what is R here? R, yes, anyone? What is R? Universal gas constant, right? That is R. Do you remember the value of R? Yes, 0.0821 we can say, but not gram. It was not gram. 0.0821 liter ATM per mole Kelvin, right? That is R. If you are getting confused with the unit, Afan, you can do like this. PV equals to nRT. Rearrange the equation. Isolate R. Isolate it. When you isolate R, it becomes PV over NT. P, the unit of P is ATM, V is liters, N is mole, T is Kelvin. Afan, rearrange like this and then try to derive the unit. Then you will get exactly this, right? Okay, so we did this last time and we derived different equations. One of the equation was Boyle's law, that is P1 V1 equals to P2 V2, and we discussed the graphs and everything. Today we are going to discuss the other different equations. The next equation is Charles law. And this is the graphical representation. If you look at this graph, it is volume versus temperature. It means in this equation, PV equals to nRT, we need to understand the relation between volume and temperature. Relation between this. Isolate volume and temperature, isolate them. Bring this T here, take this P here. You know how to isolate. So what is V? V over T is NR over P. And what is NR over P? Because I said only these are changing, rest all are constant. So NR over P is constant. That constant I can take it as K. So V is equal to KT. All these things we did earlier also. So from here we have the relation that volume is proportional to temperature. Means as the volume increases, what happens to temperature? As the temperature increases, let's discuss like this. As temperature increases, what happens to the volume? Increases. And that's what you are looking here in the graph. That's what we can see here in the graph, right? So I'm going to clear it. Now let's see. One second. Let's see these graphs. So volume is directly proportional to temperature. So graphs are straight line. Different gases have different molar masses. So lines are not overlapping with each other. But can you see that when all these lines are extended in the and they are extended to meet this axis, they all are meeting at the same point. You can see this. So at minus 273 degrees Celsius, what's the volume of the gases? at minus 273 degrees Celsius. What's the volume of the gases? Yeah, answer it. Look at this. What is this point called, Arjun? Zero, yes, is zero. And what is this zero called as? It means, what is the meaning of this zero? That volume volume of gases is zero. Do you think this is correct? Do you think gases can have zero volume? Nothing can have zero volume, right? Nothing can have zero volume. So it means they are not gases. It means at this temperature, gases do not exist. Can I say that? Gases do not exist at this temperature. Don't exist. Why? Because we cannot say that volume of gases is zero. This is an assumption. By the time you reach such low temperature, by the time you're reaching such low temperature, then gases, they cease to exist. They do not exist. They're already in solid and liquid form. Is the condition clear? And this is derived from Charles' law. And what is Charles' law? That volume is directly proportional to temperature. Can you see here? This scale is in degrees Celsius. Children, pay attention to these two graphs. See the difference? Difference is only in the scale. Can you see the unit of temperature here? Here and here? Minus 273, we already know that minus 273 degrees Celsius is 0 Kelvin. It's called as absolute zero. This is derived from these graphs, from Charles' law. It's very difficult to see this temperature in normal labs. Don't think that, oh, I'll go in the lab and I'll bring the temperature to 0 Kelvin to observe it. No, you cannot. Getting such a low temperature is impossible. Yes, scientists can do. They can reach up to 0 Kelvin, but not below it. So that's the lowest possible temperature on Earth. Lowest possible temperature. That's the reason they have drawn the dotted lines. Can you see? It means hypothetical condition. It cannot be achieved in normal labs. Is the meaning of absolute zero clear? So if somebody is talking about absolute zero, what all you are going to tell about this? First, you're going to say it is 0 Kelvin. First thing, right? Arjun, what you are writing? You're trying to say volume. Yes. Second, volume of gases is zero. So definitely it's an hypothetical condition. This is for gases only. So you are not going to say this. You will say gases cease to exist. Cease to exist. This is how you will see the language in the books. And third, you're going to say it's the lowest possible temperature on the earth. Lowest possible temperature. Because somebody will say, do you think we can have minus 12 Kelvin? Do you think so, children? Can we have minus 12 Kelvin on the earth? No. Kelvin is never negative because the lowest is zero. There is no below zero, right? Is it clear to everyone? Okay. So I'm going to clear this. And this is Charles' law. So in Charles' law, mathematical form. Now help me with the mathematical form. You know V is proportional to T. Remove the proportional, KT. Rearrange the equation. V over T is K. What's the mathematical form of this law? Mathematical. The one which I can use in questions. V1, T1. If initial volume is V1, initial temperature is T1, then V1 over T1 is K. If I raise the temperature to T2, volume changes to V2, that is also equal to K. So mathematical form is V1 over T1 is V2 over T2. Naisha, is it okay? Naisha, you're there, Naisha? Hmm. You remember all these things we did in the last class? Okay. So now let's see experiment. Let's perform an experiment to see the validity of this Charles law. Experiment. We all are doing an experiment now. There is a balloon. Balloon. You have seen balloons, right? At 20 degrees Celsius. I raise the temperature. Let's say this is T1. I raise the temperature to 40 degrees Celsius. Temperature T2. So what you have observed in a balloon when the temperature goes up, what happens to the volume of the balloon? Increases. So can you see that at low temperature, volume is less. At high temperature, volume is high. Now, what is the reason behind it? That we are going to learn in kinetic molecular theory. I'll explain you what is the reason. So at that time, we can understand the reason. Right now, this is just an experiment. So when we raise the temperature, volume increases, keeping pressure and amount constant. These two are constant, right? We are not changing the pressure. How can you say that we are not changing the pressure of the balloon? So the pressure inside the balloon and outside the balloon should be same. So whatever pressure is here inside, whatever pressure is outside, same pressure is inside. Outside pressure we know 1 atm. So what's the pressure inside? 1 atm. When you raise the temperature to T2, what is the pressure outside? Still 1 atm. So what should be the pressure inside? 1 atm. So this 1 atm is not changing. So that is the reason volume has to increase. So I'll discuss this part in kinetic molecular theory. Everybody is okay with this? Charles law? Okay. And the graphs are okay? Okay, now let's see this question. This concept here is, I don't think it's a question. So can you check the amount in each balloon? Count the amount in each balloon. 1, 2, 3, 4, 5, 6. 6. 6. I think it's same, right? So N is constant in all the 4 balloons. What about pressure? What's the pressure outside? Outside the balloon, what's the pressure? 1 atm, atmospheric pressure, if I take it at the sea level. So what's the pressure inside Azuni in all of them? 1 atm. So pressure is constant, right? So amount is constant, pressure is constant. And if the temperature is also constant, What will happen to the volume of each balloon? Same, isn't it? Same. These are the multiple choice questions, which you can understand like this. Even without Charles' law, you can understand. Volume is PV equals to nRT. So what's the volume? nRT over P. For the first balloon, nRTP. For the second balloon, third balloon, fourth balloon, N is same, R is constant already, T is same, P is same. So what will happen to volume when you plug in the values? Same for all balloons, right? Why? Because N, T, P, R is constant, are same. So this is a multiple choice question. Is it okay? You can calculate the volume also from the condition given to us here. Read this question. Can I calculate the volume? Volume of this balloon. Yes. Can we calculate? So volume of the balloon is the N is given. See this one 0.041 and R 0.0821. Temperature is given. Do I need to do anything with the unit of temperature? You go from degree Celsius to Kelvin. So 25 plus 273. Am I right, Arjun? Divided by pressure. Is pressure given? 1 atm. Can you calculate all these things? Are you getting 1 liter, children? Is this value equal to 1 liter? Yeah, so yes, nearly 1 liter. Thank you very much, Arjun. So you're understanding this, children? So you have to understand this law in parts. PV equals to nRT, in parts like Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law, but as complete law also. So questions can be very twisted, but if you have a good understanding, you can answer them. So start practicing on the website. Start doing questions. KPO means, Arjun? I'm asking from you, what is KPO, the one which you have typed? Okay, no problem. 45. Let's do this question. All of you are doing? 11.2 liters of gas is determined to contain 0.50 moles of N2. Same temperature and pressure. How many moles of gas would be there in 20 liters? Oh, we did the Avogadro's law. Azuni, we did the Avogadro's law. How come this question is here? Oh, here. Yeah, first I have to explain this. The next law. This time I'm going to keep the temperature and pressure constant. They are constant. So what's the ideal gas law? Afan, Vivan, PV equals to nRT. Can you isolate volume and N in this equation? Isolate them and give me the rearranged equation. So in Avogadro's law, only volume and N are changing. Are changing. Ariba? Afan, Vivan, Ariba, answer it. Nivriti? See, Vivan, N will go in the denominator, right? Vivan. Here it is in the numerator, so it will go in the denominator. So V over N. Very good. Naisha. RT over P. What is it, children? R is constant, T and P are constant. We are doing experiment at constant temperature and pressure. So this is constant, right? So can I say V over N is a constant, K? This constant include temperature and pressure, right? So can I say V1, N1, when the amount is N1, volume is V1, is K. When the amount is N2, volume is V2, that is also equal to K. So what's the mathematical form? Is it right? Okay, now all of you are going to define this law. Okay, children, after understanding the concept, you should be able to define the things, which not so important in chemistry, but they are very important in physics. In physics, definitions are very important. So, and definitions, their language is very, very important. In chemistry, yes, definitions are there, but we don't give them so much importance. So, we are going to define it here. If N1 equals to N2, if, then what's the relation between V1 and V2? If these two are equal, don't you think V1 is equal to V2? Yes. Now define. These means equal moles, right? Define it. Equal moles have equal volumes. Can I define it like this? Equal moles. If you have equal moles of a gas, then they are going to have equal volume at constant temperature and pressure. Constant temperature and pressure. This condition is very important. Only then it is valid, otherwise no. Can you see the definition, children? Azuni? Naisha, definition is clear? Can you help me, Naisha and Ivriti, in another definition? See, this definition is written here. Okay, let's define it again. This is one definition. You can see it in the books. Avogadro's law is defined like that. Equal volumes, equal moles have equal volumes at the constant temperature and pressure. But if let's say, now I'm changing the condition, children. Check. If I'm changing the condition, V1 equals to V2. So This is the law. V1 over N1 equals to V2 over N2. I'm saying V1 equals to V2. So what's the relation between them? Can I say N1 equals to N2? Now define. The way I defined here, this is equal volumes, equal moles. Define in this manner. All of you, please type the definition and define the condition also. You have to say the condition under which this is valid. Yes, Afan, come back fast. Equal moles have, but this time I defined equal volume. I gave you equal volumes. So you have to start like this. The way Azuni is defining equal volumes. Start with equal volumes. Have equal moles. No, Arjun. Vivan, equal volumes have equal moles. You want to say that, right? Yes, the way Ariba has defined. Equal volumes have equal moles if temperature and pressures are constant. Are we okay with these definitions? Now let's see the application part. This is your Avogadro's law. Now let's see the application part. Let's say this balloon, this one, is 1 liter. This is also 1 liter. This is also 1 liter. Please answer my question very carefully and very smartly. From my side, you should be able to answer it now. If I give you 2 moles of nitrogen, if I say there are 2 moles of nitrogen in this 1 liter of the container, of the balloon, sorry. 1 liter of the balloon has 2 moles of nitrogen. All the 3 balloons are at the same temperature and pressure, all of them. Then how many moles of N2 are there? And how many moles of helium are there? These are 3 balloons with equal volumes at the same temperature and pressure. Balloon number 1, hydrogen, has 2 moles. So how many moles in N2 balloon? 2 moles, yes. They all are going to have 2 moles. Is it clear to everyone? Vivan, is it clear? Vivan. Okay. Afan, you're back. So equal volumes have equal moles. That's the concept we are doing, right? Provided temperature and pressures are same. So these type of questions are there as multiple choice question. Children, they will appear very tough if you don't practice. But if you practice 5, 6 such questions, you will take them as fun. Within seconds, you will answer. Now I'm changing my question, children. Please analyze and then answer. Out of these 3 balloons, first answer this. These 3 balloons, are they going to weigh same? The mass is same, the weight? Or the weight will be different? I'm talking about their weight. So when I'm going to weigh hydrogen balloon, nitrogen balloon, and helium balloon, do they have the same masses? Yes or no? Okay, what about you? Children, I want to tell you, Nivriti is doing quizzes very regularly. I was checking, I was trying to take out the report. She's so regular and so smart on the website. And her answer is also right. Arjun Azuni, can you tell me moles, 2 moles, what's the mass of 2 moles of hydrogen? What's the mass of 2 moles of hydrogen? No, Arjun, again wrong. 4 gram. 2 moles. 1 mole is 2 gram. What's the mass of 2 moles of nitrogen? 1 mole is 28. 2 moles is 2 times 28. Arjun, again wrong. What's the mass of 2 moles of helium? 2 times 4. So is the mass same, Arjuni? Moles are same. Same number of moles doesn't mean that masses are same. Mole is a number. You can say they have same number of molecules, they have same number of moles, but you cannot say that they have the same masses. Masses are different. Unit 1, 1.1. Okay, Suni, no problem. Is it okay? Is it clear, Azuni, now? So which one is the heaviest? Which balloon is the heaviest? N2. Vivan, you are understanding this? Okay, Afan. Ariba, is it clear? Naisha, I'm not getting your answer. Yeah, okay, good. Somebody can explain, Arjun? He's asking something. He's saying nitrogen balloon should be 24 grams. Is there anyone who can explain this? It's 2 moles, Arjun. Please practice quizzes. It's 2 moles. What is the mass, molar mass of N2? It's 2 times 14. It's 28 grams per mole. And if there are 2 moles, multiplied by 2. Right? Practice quizzes. Practice makes you perfect. Okay. So that's the Avogadro's law. Don't think, Arjun. Observe also. Your observation should be very good. Okay. In the question paper, if N2 is written and you are thinking N, that will be wrong. Your answer will be wrong. So first, focus on the question. See everything very carefully and then answer. So what I just told you that if volumes are equal, equal volumes means equal moles, right? Provided, provided temperature, pressure, constant. This is one thing which we have understood from here. Second important thing is STP condition, which we have done earlier. Anyone, do you remember STP condition? Temperature, 0 degrees Celsius, which is 273 Kelvin. Pressure, what is pressure at STP? Ariba? 1 atm. And what else? Now, equal volumes have equal moles at constant temperature and pressure. If I say there are two gases at STP, two gases, then it means temperature and pressures are same for both the gases. Then there is one more condition that at STP, 1 mole of any gas is 22.4 liters. This is the major thing. You're understanding this condition, children? Remember we derived the value of R at STP, PV equals to nRT. Isolate your R. R equals to PV over NT. Plug in the values STP condition. Plug in P as 1 atm, V as 22.4 liters, N as 1 mole, T as 273. Then you get the value 0.0821 liter atm per mole Kelvin. The value which we are using every time is defined at STP. Is it okay? If this concept is clear, I'm going to ask few questions then. Based on this, I want you to smartly answer it, okay? Take your time, but answer it smartly. STP condition is valid for Avogadro's law. Let's say there is N2 gas, 4 moles at STP. Calculate volume. Calculate volume. Yes, children. That's the question. Okay, Arjun, what you did? Yeah, plug in this ratio, children. Arjun is right. So 4 moles of N2 at STP, plug in the ratio, this ratio, that at STP 1 mole is 22.4 liters. 22.4 liters in the numerator and 1 mole in the denominator. Cancel, cancel, and you will get the answer which Arjun is telling us and everything. Naisha, is it okay? This mathematics is okay? Naisha. Naisha, are you there? I'm waiting response from you. Okay. I hope you're understanding. Start answering, okay? Just no, don't type yes or no. Answer also. No, no, no problem, Naisha. You're not slow. Please. Naisha, you are very smart. I have seen you. Okay. Ready, children? We are good for next question. Next question. There is CO2 gas and the volume is 44.8 liters. Can you get the mass of CO2? These are very fun questions. Mass of CO2. You know that to know the mass of CO2, you should know moles of CO2. So aim is to know the moles of, and this is at STP. Condition is at STP. So once I've given you the condition STP, I don't think it's a difficult task to calculate the moles. You can use this ratio. 1 mole at STP is always 22.4 liters for all the gases. If it is 44.8 liters, then you plug in this ratio. Only Arjun is answering very fast. What about rest of you? Okay. How come, Naisha? So how many moles were there? Arjun, how many moles? Naisha, how many moles? And then the molar mass. And molar mass of CO2 is 44 grams per mole. That's the dimensional, isn't it? So we are good with this? Only Naisha, Arjun are interacting. What about rest of you? Not doing at all? Afan? Okay, you're here, but is this clear? This concept is clear, Afan? Is it clear, Afan? STP condition. Okay, if you have understood, one last question on STP condition, and I want answer from the children who are not answering. Okay, Ajuni and Arjun and Naisha, you will not answer. So let's see others. Okay, there is a container. You will answer it, start thinking, but not first. Hold your answers, Arjuni, Naisha, and Arjun. There are three conditions, three containers full of gases. These containers, all of them are of 2 liters. 2 liters. All of them are at STP. STP. And yes, Naisha, you can answer it in the private chat. All of them are at STP. One container is helium, other container is CO2 gas, third container is N2. My question is, out of these three containers, which container is heaviest? So when I say heavy, means mass. So it means you have to check which container is heaviest. So first we have to think about their moles and then mass. These are the containers at STP. The volumes are equal. So which container? Equal volumes have equal moles. So all the containers have equal moles, right? Ariba, so which container is heaviest? Afan, Vivan, Nivriti. No, equal volumes are given. Naisha, equal volumes. Equal volumes means, okay, what about others? Ariba and Vivan. Can you explain, Vivan, why CO2? CO2 is the answer. Afan, you didn't answer. Afan, where is your answer? Okay. So now Vivan is going to help us in understanding why CO2 is heaviest. So CO2 is the right answer. But why is it heaviest? Because equal volumes, these are equal volumes at the same temperature and pressure have equal moles. So number of moles of helium will be equal to number of moles of CO2, which will be equal to number of moles of N2. Now moles are same. Now which one has highest molar mass? CO2. Helium is 4 gram per mole. CO2 is 44 grams per mole. And N2 is 28 grams per mole. So if their moles are same, then it means this is going to be the heaviest. Okay. But generally we discuss in terms of moles and grams, not in terms of density, Vivan, right? Yes, because the moles are equal, so you just take the highest molar mass. Naisha, now you start answering in the general chat. Naisha, can you place this thing which you are asking here in the direct message? Put it in the general chat and see children what she is writing. Naisha, can you put it? And what she is writing is a shortcut. If moles are equal, she wants to say moles. Moles are equal, then you just compare molar masses. So write it down. Write down this line. It's a trick. So if you see there are containers with equal moles and they're asking you to compare the weights, then you just compare molar masses. Yes, Arjun, your answer was very good. Perfect, Arjun. Naisha, good. Very good line. So we are good with this? Avogadro's law. Ready for question? Afan? Good. Let's see this question. My advice is go and do quizzes. Don't delay them. Delaying means you have to watch the recording again. You have to understand everything again. It will double up the time. If you are doing the class, going for the quiz, reading the book or the notes over there, practicing few questions and do the quiz, it will take less time. But if you wait for 1 month or 2 months or 3 months, or when your teacher is going to do, then you have to watch the recording again. You have to understand everything from starting, which will be a difficult task. Okay, question 45. 11.2 liters sample of gas is determined to contain. Volume is given, moles are given, n. N is the number of moles, right? N. Same temperature, pressure. Avogadro's law. How many moles? So it means this is N1 and then they are asking N2. When the volume changes to V2, so we have this law. V1 over N1 is V2 over N2. You can write it like this, or you can write it like this also. It's the same thing mathematically. They are asking you to calculate N2. Yes, Arjun. So just rearrange the equation. Rearrange this equation. Isolate N2. Isolate N2. We want N1 V1 times V2. How much is this? Plug in the values. N1 is 0. Look at the question. V1 is 11.2 liters. These are moles. Plug in the units also. This is liter. V2 is 20 liters. How many sig fig? Answer should be in why? Why, children? How many sig fig in this number? There is a decimal. 2. So why you are taking 3? And even this number is 2. This is also 2. Leading zeros are not counted, right? So answer is no, Arjun. Still not correct. Now you are giving me only one sig fig. Arjun, I think you are counting this 0. Leading zeros are never counted. So it is 0.89 liters. Yes, Naisha, you will. In free response, you will lose marks. Even in MCQs, but in MCQs, I have never seen AP people troubling us with the sick way. But free response, yes. When you're writing the answers the way I'm writing, then you have to be very careful with sick fig. It's written there. Take care of the significant figures, rounding off. It's written. Approximations. Okay, so we are good with this question. Anyone has any problem? Ariba, question is clear? Moving on. Okay, let's do this question. This Avogadro's law has a beautiful application on reactions. Now, let's say I'm carrying out this reaction in a container. This is the container. I'm carrying out the reaction. These gases are present in this container. During the reaction, they are present. So these gases is automatically they are at the same temperature and pressure. Same temperature and pressure because reaction is carried out in the same container under the same similar conditions of temperature and pressure. So every reaction in which gases are involved, you can assume or you can take these gases at the same temperature and pressure. So Avogadro's law is valid. Here, Avogadro's law is valid, right? Now, how to do this question? How many moles of NO2 are here? 2. And this is 1. Now, because I said that here the conditions of temperature and pressure are same, so I can relate the volume with the moles. If this is 2 moles and this is 1 mole. But children, this is not STP condition. Remember that. If the volume of this gas is V liters or milliliters, let's say milliliter, V milliliter, what is the volume of this gas? Equal moles have equal volumes. But if the mole is doubled, these are not equal moles. Are they equal, Naisha? So if this is 1 mole, then it has to be 1 mole is V milliliter, 2 moles will be 2V milliliter, doubled. Is it okay? So it means volume of NO2 gas will be double of the volume of N2O4. So what I'm trying to say, if there is an equation like this, you can read the equation in terms of volume. Right now it's written in terms of moles. I can read the equation in terms of volume. I can say 2 volume of NO2 reacting to give 1 volume of N2O4. Is it okay, children? Now you can take this ratio to answer this question. Waiting for your answer. What is given? So in every question, check what is given. This, start with it. 25.0 ml NO2. What do you know? This ratio. This ratio, right? What do you want to calculate? N2O4. So keep this 1 volume of N2O4 in the numerator. 2 volumes of NO2 in the denominator. What's the answer? 12.5 ml. So I'm doing this question to make you understand. Next question you people are going to answer. So if you have any doubt, please ask. It's very easy to understand. 2 volume is giving you 1 volume. If it is 25 ml, then it will be half of 25 ml. 25 divided by 2, which mathematically also I explained you how to do it. Anyone has any question? Vivan? Because next question I will force you to answer it. Vivan, Afan, I'm expecting good answer. Okay, Vivan, Afan, is this concept clear? Afan, I think. Okay, no questions. Afan, start asking questions. Children, the class in which students are asking questions, I really enjoy that class because I've seen their answers are very right after that. I don't know why you people hesitate in asking questions. There's no peer pressure. We don't know each other, right? For me, all of you are very smart, working hard, and that is more important. Okay, for parents also, you people are working hard and good children. Okay, so please ask questions, don't hesitate. So everybody has said yes, so I'm going to place one question from my side. N2 is a gas reacting with 3H2, which is a gas, giving you 2NH3, which is again a gas. This is balanced equation. Equation has to be balanced always. If I give you 2 liters, they all are present in the same container at the same temperature and pressure, right? If I give you 2 liters of N2, can you tell me from 2 liters of N2, how many liters of ammonia can be formed? How many liters of ammonia can be formed? As I said earlier, that you can read the equation in terms of volume. 2 volume, 1 volume, like this. So can you read the equation in terms of volume, this one? This coefficient is 1 liter of N2 reacting with 3 liters, this 3 of H2, giving you 2 liters of ammonia. So you know this. You know this ratio of the volumes. Answer it. This is given. Start with what is given. Plug in the ratio. Ratio of ammonia with N2. Mhm. Okay. Vivan, Afan, please ask questions if it is not clear. Ariba, okay. Nivriti, Nivriti. Okay, so now Afan is asking a question. Afan, that's good that you have asked a question. Can you see this balance equation, Afan? What is the coefficient of N2? 1. Coefficient of H2? 3. Okay, Nivriti. And coefficient of NH3? 2, right? So, Afan, you can read this equation in terms of volume because they are all are present at same temperature and pressure. So, if this is 1 mole, I can take this volume as 1 V or 1 liter. Take it as 1 V, 1 V. Then the volume of H2 will be 3 times of that, 3 V. And the volume of ammonia will be 2 times of N2, 2 V. This coefficient. So, I know that 1 volume of N2 is equal to 2 volume of ammonia. That I know. I will use this ratio here. What I want? Liters of ammonia. Plug in this ratio. 2 volume of ammonia, just like the way you were doing molar ratio over 1 volume of N2. N2, N2 cancelled. VV cancelled. Answer is 4 liters. Yes, Arjun. That's the right answer. So we are good with this? Okay. One more question before I end it. Based on what we were doing here. So here I said I've given you 2 liters of N2, but now I'm giving you 10 liters of ammonia. 10 liters. I want to prepare 10 liters of ammonia. Can you tell me how many liters of N2 will be needed and how many liters of H2 will be needed? Just see the ratio. It should be very fast. This is N2. Very good. Very good. Afan and Arjun, 5 liters. And H2? N2 will be 5. Yes, Arjuni, good. H2? Niriti, perfect. Naisha, you're getting it? H2? For H2, you will start with 10 liters of ammonia and you will plug in the ratio. What is the ratio? 3 volumes of H2 over 2 volumes of ammonia. So answer is 15. Very good. 15 liters. Take care of the units. Okay, so these type of questions, real fun questions based on Avogadro's law. Avogadro's law can be applied on a reaction in terms of volume. So whenever you see a reaction in which gases are present, you can compare the moles as the volume. 1 mole of gas can be taken as 1 volume. 2 moles will become 2 volume. 3 moles will become 3 volumes. Okay, let's do this question. So here, two 200-liter tanks. So there are 2 tanks. And what's the volume of these tanks? 200 liters. So they both the tanks are of the same volume. Volume is same, 200 liters. One container has helium, other container has hydrogen. What mass of each gas is needed to give a pressure of 2.70 atm? What is the pressure in both the containers? 2.70 atm. What's the temperature of both the containers? 24 degrees Celsius. So can I say both the containers have equal volumes and they are at the same temperature and pressure? Can I say? If they are equal volumes, what about their moles of hydrogen and helium? What about the moles? Equal volumes at the same temperature and pressure have equal moles, isn't it? Avogadro's law. V1 over N1 is V2 over N2. Now V1 and V2 are equal, 200, 200. So it means N1 and N2 are equal, right? Can I say that, children? Equal volumes have equal moles. So which container will be heavy? Answer it correctly. And I won't answer from all of you. Don't try to explain it. Just answer. Which container is heavy? Helium or hydrogen? Just answer it. Okay, Ajuni. Ajuni is saying helium. What about rest of you? Okay. Okay. Afan, which container is heavy? Yeah. Now who is going to tell me why? You remember Naisha wrote one line. that if moles are equal, compare the molar masses. She wrote that, right? I told you that. Write it down. It's a trick. You can use it. So the one with higher molar mass, helium, 4 gram per mole. This is helium is 4 gram per mole. And hydrogen is 2 grams per mole. So that's the reason. But the question is, okay, question is not this. If you see, they are not asking that which one is more heavy. They are asking what is the mass. They're asking you to calculate. Mass is not 4 gram. That's for 1 mole. I don't know how many moles are there. So they are not asking which one is heavy. That's the question from my side. That you have answered very correctly. But now the question is, what is the mass? To know the mass, I should know moles. If I know the moles, I know the mass. Correct? How to know the moles? Ideal gas law. Arjun, no, it's not STP. Is this condition STP, Arjun? So don't use that ratio. Okay? You can use this ratio only on STP. So that is the reason I didn't use that ratio. Arjun is saying 22.4 liter is 1 mole. So he is trying to use that, but that's not valid. I don't know the answer, Arjun. So I'm going to calculate it. So wait for it. So I want to calculate N. So N is PV over RT. What is P here, children? 2.70. V, 200 liters, right? R, 0.0821. Temperature, convert this in Kelvin. Kelvin is 297 Kelvin. Calculate it. Calculate this, children. These are the moles. Rest all units will cancel out. So how many moles? Anyone doing calculation? Vivan, Afan, you can do calculation very fast. Afan, calculations. Show me the calculation. No, yes answer. Okay, I want calculation. Please. It's not you should not be relaxing when rest all are doing calculations. How many sig figs? Afan, you're not you're doing it. Okay, good. So how many sig figs, children? Take care. See all the sig figs. How many sig figs? Why? Check the sig fig here. 3 here, 4 here. This we are not going to consider. It's a constant. And 3 here. So answer should be in 3 significant figures. 22.1 moles. So how many moles of helium? 22.4. 22.1 moles, right? And how many moles of hydrogen? 22.1, same. So what is the mass of helium? What is the mass of this container? Mass will be moles multiplied by molar mass. So 22.1 multiplied by molar mass is 4 grams per mole. And you will get the answer here. Yes, Arjun is giving us. And here it will be 22.1 moles multiplied by molar mass of hydrogen, which is 2 grams per mole. And you will get the answer here. And then you can compare and you will find this is heavier because of high molar mass. We are understanding this, children? Afan? Very popular questions. Very, very popular. And yes, they are fun questions. And you will forget these questions if you don't practice. They will become very difficult if we don't, if we are unable to visualize and practice these questions. Read the questions, get the information, check your answer all the time. I'm uploading a book also there. In that, I'm taking question from that book. You can see 49 question there. Even I have uploaded the solution manual. So you practice the questions, alternate questions. Don't do, there are 100, 200 questions. Don't do all of them. Just alternate and keep checking your answers from the solution manual. If it is not clear, read the solution manual. Still not clear, post it on my forum. Children, your life is right now, you have nothing else to do. Your parents are taking care of everything. We are lucky. Our parents are doing so much work for us. So spend your time in learning, learning in depth, and make your future. More you learn, more you practice, more you shine, more better future you will have, and accordingly, it will make your parents more happy and their future will also become good. Right, children? So please work hard. Use your time properly. Okay, now combine gas law. So here is a question. What was the Boy's law, children? What was the Boy's law? V is, volume is inversely proportional to the pressure. Remember P1 V1 equals to P2 V2? P2 V2, right? So V is inversely proportional to pressure and V is directly proportional to temperature. What was this? And V is directly proportional to N. What are these laws? First, Boyle's law. Second, yes, Arjun, Charles' law. Third, third, Avogadro's law. What about rest of you? Boyle's law, Charles' law, and Avogadro's law. No, no, no problem. Hasuni. Okay. Naisha, I know it's slightly difficult to retain, but you have to practice, okay? Combine them, combine these three important laws. These are the most important laws. Combine them. So if I combine them, I'm getting volume V, this V, here V, proportional to temperature directly, amount N over P. Remove this proportional. Okay, I'm sorry. I think I started deriving ideal gas law. No, ignore this one. Just combine these two important laws. Ignore the third one. If I use the third one, I will get ideal gas law. Ignore it. Now combine these two. Remove this proportional. So V is equal to K times T over P. Isolate K. Isolate this K. So Afan, can you write down the isolated equation? K on one side, rest of the things on the other side. Afan and Vivan. Can you give me the equation? Very good. Very good, Afan. So he's saying PV over T, and I think he's perfectly all right. Sorry. If I give you first condition as P1 V1 and T1 means when the pressure is P1, volume is V1, and temperature is T1. And the second condition, pressure changes to P2. Accordingly, volume changes to V2, temperature changes to T2. Then you are getting this law, which I discussed earlier also, and is called as combined gas law. Is it okay? So there are questions based on it. So there will be questions in which you have to see that which law we have to use here. Read this question. Children, it's a lengthy question, so I will help you. So they are talking about bicycle tire filled with air. Pressure is 75 psi. You remember psi, pound square inches? I told you that tire tube pressures is measured in psi. Temperature is this. Riding the bike. So I'm writing here. Pressure of the tire tube is 75 psi. Temperature is 19 plus 273. Without any question, you have to convert this into Kelvin every time. Oh, you cannot see it? Oh my God. Mm, sorry. Can you see it now? Can you see it now? Okay. Sorry. I think by mistake I pressed the button of stop sharing. So somehow I was explaining you so many things. Okay, read the question. So combined gas law was okay with us, right? P1 V1, P1 V1 over T1 is P2 V2 over T2. Okay, now I'm applying this law on this question. How to know that I should apply this law? You just start collecting information. There is a bicycle tire filled with air at a pressure this. So I'm writing pressure of the bicycle tire as 75 psi. There is no need of you changing the unit right now because here I'm not using R. There is no R here. So don't worry about the unit. Only thing units has to be same on both the sides. But temperature definitely in Kelvin. In Kelvin. Definitely every time. Riding the bike on a very warm day increases the temperature to this. So there's a change in temperature. So can I say this is T1? So what is T2? 58 plus 273, right? The volume of the tire increases to 4% because temperature is changing. They are saying new pressure also. They are talking about new pressure. You know that when the temperature changes, pressure also increases. So they are asking for new pressure. P2 they are asking. P2. Is V1 given to you? No. So let's take it as V1. Is V2 given to you? The volume of the tire increases by 4%. Means it is V1 plus 4.0% of V1. Mathematics. Can I say that? So it is V1 plus 4V1 over 100. So how much is this, Arjun? Children, are you getting this? Read the line carefully. They have not given me the volume of the tire tube. Volume is not given. So I assume the volume is V1 initially at this temperature and at this pressure. This is the condition P1, T1, V1, right? Now they are saying the volume is increased by 4%, means the new volume V2 is V1 plus 4 point plus increased plus. Why it is plus? Because it's increasing, right? 4.0% of V1. Afan, is this mathematics okay? This is mathematics, children, not chemistry. Afan? Okay, good. Can you work out this, children, now? Is it 104 V1 over 100? Can I say that? This is V2, right? What are they asking? P2. Isolate P2 here. Isolate P2 from the combined gas law. You can see P1, T1, V1, T2, V2 are given. So I'm going to use combined gas law. Isolate P2. So P2 will be P1 V1 over T1 times T2 over P2. Am I right? See, I'm isolating that. I'm isolating, oh, over V2. I'm just isolating this P2. Naisha, mathematics, right? Isolate this P2 which you want to calculate, the new pressure. Plug in the values. What is P1? 75 psi. What is V1? V1, I don't know. V1 only. What is T2? This one. How much is this? Kelvin. What is T1? T1. And what is V2? This one. V1 cancelled. Kelvin cancelled. I'm left with PSI. My answer will be in PSI, children. Pounds square inches. Okay, solve it and you will get the P2 pressure. Can you see V1 is not interfering now? V1 was not known to me, so I plugged in as such. V2 also I derived in terms of V1. This V1 cancelled. So there is no V1. And then you can calculate the answer and the answer will come in PSI. Can you check the answer, children? No, Arjun, your answer I think is wrong because, yeah, pressure will increase, but not so much. Okay, children, can you calculate it? It's 81.7. Answer is 81.7. Some error of the zero, assuming. 81.7 units. Vivan, Afan, you are not doing any calculations, or are you already in the mood of just leaving the class because time is nearly up? Why you people are not interacting? Ariba, you're doing the calculation, Vivan? Good. Now I want you to compare this pressure, 81.7, 81.7 with 75. Can you see that the pressure has increased? Why? Because the temperature is increasing. So what will happen if you keep increasing the pressure? What will happen to that tire tube? It will burst. At high temperature, you must have heard about the tires of the cars and trucks, and they explode. Why are they exploding? Because of the friction, the heat is generated, and the temperature is also very high. So the gas is expanding. So volume is trying to increase, but every tire tube has a limit of volume. So when too much of expansion is taking place, it will burst, just like a balloon, right? And there are many accidents also caused by this. Okay, children, so that's about your questions based on these laws. There are many more, but if I keep doing these questions like this, then it's going to take much time. Maybe I can do few more. There are three more which I want you to do, but that's fine. We can continue in the next class. And in the next class, I'm starting the new topic, kinetic molecular theory. Very important topic, children, because most of the explanation part of what you are learning, you can learn the basics, the concepts behind it in kinetic molecular theory. Plenty of questions will be there. If you have any question, you can stay back in the class. Oh, I think we are left with 3 minutes. Is it okay if I do one more question, children? All of you are here, right? Let's do one more. Okay, let's do one more. I didn't see the time. We are still with 3 more minutes. Afan, okay? Two separate gas containers. Their volumes are different. You can see container A, gas is this, pressure is PA, moles 1, volume this, temperature this, pressure is this, moles is this, volume is this, and temperature is this. How is the pressure in container B related to pressure in container A? Yes. See, they have given the moles, volume, everything. So I can use this law. PA, VA, P1, V1 over TA. But here moles are also changing. So I cannot use combined gas law. Remember PV equals to nRT. Now is the pressure changing? Yes. PA to PB. Volume? Yes. N? Yes. T? Yes. Moles are changing. So I will use this. PV over NT is R. I'm going to use this. What does it mean? Because everything is changing. P is changing, V is changing, N is changing, T is changing. So isolate these, isolate R. So can I say PV over NT is K? And I can modify it. PA, VA, NA, TA is R. Agreed, children? So TB, VB, NB, TB is also R. So don't you think that they are equal to each other? They are equal to each other. Now you have to just plug in the values and plug in VA here, NA here, take care of the units. Temperature has to be in Kelvin always. Just plug in all these values and check the relation between PA and PB, right? What Arjun is saying. But Arjun, volume is doubled, moles are doubled, but temperature is also changing. So everything is changing. So that's the reason you cannot predict. So you have to use this equation and then you have to see the relation between P and PB, right? Okay, children, so this is how we have to practice questions, plenty of questions, not one or two, maybe 100 questions. Then you can master it very well. So I'll see you then in the next class.